This is an explanation for question 21 of the 2020 AMC 8, Paths on a Chessboard. A game board consists of 64 squares that alternate in color between black and white. The figure below shows square P in the bottom row and square Q in the top row. A step consists of moving onto one of the adjoining white squares in the row above. How many 7-step paths are there from P to Q? A sample path is on the right. The first solution is the counting and marking solution. The squares marked with circles are the ones that someone can move to in order to get to Q in 7 steps. Since each circle can only be reached by a circle below it, we can figure out the number of paths leading up to a square by adding the 2 numbers below it. There's only one way each to get to the 2 squares on the second row. With these 2 numbers, we can keep adding on to get the number of paths on the squares above, like so. Thus, the final answer is 19 plus 9, which is 28 paths. Another solution is the combinatorial approach. Suppose we extend the chessboard to the right infinitely, with 2 extra rows from the red line. Now, we have all possible 7-step paths shown, marked with circles. All the possible paths are formed by going right up 4 times and left up 3 times. The number of paths in total is 3 plus 4, choose 3, which is 35. However, there are invalid paths, paths that cross the red line. To exclude them from our calculations easily, we can mirror the paths that crosses the red and blue dots to Q, like so, to get a point, Q prime. The paths that lead to Q prime are the number of invalid paths. There are in total 7 choose 1, which is 7 invalid paths. As such, there are 28 valid paths. Both solutions are valid solutions. However, they each have their own uses. The counting and marking solution on the left is easy to use and easy to understand. However, it is more suitable for smaller boards. If the board is too large, the numbers in the circles will be too large to calculate as well. In these cases, the solution to the right, the combinatorial method, is much more preferred. It is more widely used and it can be applied to more broad situations, no matter how big the board. These are the different usage of the 2 solutions. This is an extension, the same problem, but in a larger scale. In this situation, the counting and marking method would not be useful, since the board is too big and the numbers get too large. Combinatorics will be better suited for this problem. To get from A to B, one would move left up 8 times and right up 9 times. Thus, the total amount of paths would be 8 plus 9, choose 8. However, there is one invalid path that goes too far right, since it only extends to 7 spaces to the right. So we need to subtract that from the final answer. So the final answer should be 8 plus 9, choose 8, minus 1, which is 24,309.